Suppose we are interested in evaluating this integral. First of all, this integral has 1 divided by square root of x plus 1 plus square root of x dx. This is similar to what you did when you took the limit. But in your limit, you had a negative sign in between. This is the same process. Let us rationalize the denominator by multiplying both the numerator and the denominator and the denominator by the conjugate of the denominator. So what was the definition of conjugate? If you have a quantity like a plus b, its conjugate is a minus b. So you're going to just copy down a and b, just change the sign in between. If it's a plus b, it becomes a minus b. If you have a minus b, the conjugate is a plus b. This is your term. And this is the conjugate of the term. So what is the conjugate of the denominator? The conjugate of our denominator is square root of x plus 1 minus square root of x. So we're going to take this quantity, multiply both the numerator and the denominator by this conjugate to simplify the integral. So our integral is 1 divided by, copy down the denominator, which is square root of x plus 1 plus square root of x, and the conjugate, which is square root of x plus 1 minus square root of x, divided by square root of x plus 1 minus square root of x. Make sure to use parentheses because on the denominator, you have to multiply these binomials and you have a dx as well. So this integral is equal to, you're going to copy down the numerator. You have square root of x plus 1 minus square root of x divided by, so now do the multiplication. What do you see here? You have a plus b times a minus b. So from algebra, if you have a minus b times a plus b, this is a squared minus b squared. So when you're multiplying square root of x plus 1 plus square root of x times square root of x plus 1 minus square root of x, this guy is square root of x plus 1 to the second power minus square root of x to the second, or you get x plus 1 minus x, which is 1. Wow, my denominator is just 1. This guy here. And then dx. By rationalizing the denominator, I simplified this integral to something very simple to work with. So this guy can be written as the integral of square root of x plus 1 dx minus the integral of square root of x dx. But remember that if you have the integral of u to power n du, this is u to power n plus 1 over n plus 1 plus c. So for each one of these, it is the case that you have u to power n, because if you take u to be x plus 1, du is dx. So this integral is equal to the integral of square root of u du minus the integral of x to power a half dx, or you have the integral of u to power a half du minus the integral of x to power a half dx, which in turns is equal to a half plus 1, 3 halves, so you get 2/3 u to power 3 halves, but what is u? U is x plus 1 minus 2/3 x to power 3 halves plus c. You can leave it like this, or you can write it in nicer form, which is 2/3 times square root of x plus 1 times x plus 1 minus 2/3 x times square root of x plus c.